Can you see my screen, everybody?
Not yet.
Uh,
Yeah. No.
no? Okay, just a moment. Can you see now?
Yes, I can.
Yes.
Yeah.
Yes.
Yeah, actually, today we will be discussing about the questions and answers for the midterm exam too. Still, I am looking and grading your midterm exam too. So I hope in next class I will be sharing the results. But today I like to discuss those questions and answers for you. uh, you see, there are total 5 questions. So among 5 questions, question number 2 to 5 were the same both for undergrad and grad level. But question number 1 was different for both levels. So you see, I have written at first like code CEC 4205. This means this question was for the undergrad. But at the bottom, you can see I have written codes EC 6205. That is for the grad level. So therefore, both of you, please look the questions and then I'll be discussing the answers. This is very important. So for the undergrad, the question number 1 was, what is the motivation to use a hybrid energy storage system in a modern power grid? And then explain your answer. So actually before, during the class, few classes back, we discussed this question. So once again, you know that the question of the motivation of using hybrid energy storage. So hybrid energy storage means the combination of high power energy storage and high energy storage. So high power means that supercapacitor energy storage, superconducting magnetic energy storage, and flywheel energy storage. On the other hand, high energy storage device means battery energy storage, fuel cell energy storage, and then pumped hydro energy storage. So the motivation is that, that first of all, energy storage is needed with the renewable sources, like such as photovoltaic system and wind energy system, because their output is dependent on their input variations. Now, sometimes it happens that in case of both wind and photovoltaic, that output power is randomly varying, quickly going high, quickly going low, but sometimes the change in kind of the slower, steady change. So now when there is high change, either speed or solar irradiance, that time you need high power device. At that time, the supercapacitor or the SMS or flywheel energy storage is appropriate because they can handle the high value of power, like megawatt range of power uh, within millisecond range. On the other hand, when there is slow change, either in wind speed or the solar irradiance, that time you need high energy density device. For example, the battery energy storage or the fuel cell system. So because the change in slow, not fast. So if you use the supercapacitor or SMS in that case, then they will be charged and discharged quickly. On the other hand, the variation is slow. So they cannot cope up with that situation. So that's why you need like flywheel system, sorry, the fuel cell system or battery energy storage system. So the question is, what is the motivation? So you have to tell the motivation behind using hybrid energy storage, that sometimes there is quick variations and sometimes there are slow variations. That's why you need the combination of high power and high energy density device. That will be the appropriate answer. Is there any questions or comments from anybody?
Yes, I have a question, Professor.
Okay, please. Hello.
Question number 2. is it just for the 6205? Can you hear me, Professor?
No. So you see, as I told you, this question, so I am discussing the question first, 4205. Can you see my screen? So on top, I have written is 4205. Can you see that? And then next, the 6205. So, you know, the from question number 2, 3, 4, 5, all are the same for both levels.
Yeah, my question is question number
I cannot hear you, like there is a significant noise.
yeah, my question is, if I didn't answer the question number 2 in the exam, it's okay, or I need to answer it?
If you did
The
not,
question number 2, because it was in the exam.
question number 2, yeah, it was in the exam. You mean this question? Question number 2, you see?
Yeah.
Yeah, so it was in the exam for both.
So it's okay if it's okay if I didn't answer the question, or is it for both 4205 and 6205?
That is for both. If you don't answer anything, then you will not grade for that question. So what do you mean that you didn't answer? You see, do you understand what I am explaining? You see, look, the 6205 question number 1, this question number 1 was not for you. So you didn't need answer during the exam. But today I am discussing both for your understanding. Like each of you, you look, what was the question? Now I am discussing just for your learning. You see, the question number 1 for 6205. This question was not for you. Question number 1 from 6205. That was not for the 4205. Similarly, the question number 1 for the 4205 was not for the graduate level. So that is fine. But what now I am discussing, like for your learning purpose, you have to understand this. Do you understand now?
Yeah. Yes.
Yeah. So you mean that you did not answer question number 1 for the 6205, right? I think you mean that one.
It was question number 1. It's not in the exam, but question 2, it was in the exam.
Yeah. So question number 1 for the 6205 was not for you, for the 4205. There are two question on, one for 4205 and then on for 6205. So you don't need to answer 6205, question number 1. Okay.
Okay, thank you.
Yeah. Okay. Now see, again, like moving back, question on B for 4205. Everybody see? Low pass filters eliminate harmonics in power grids. So you all know the function of the filter like smooth out the performance, eliminate oscillations or harmonics from any variables in power grids. But do they have any drawbacks? So yes, there is drawback. The drawback is that they will introduce some sort of delay. Because if you see the block of low pass filters, it is typically like on over on plus ST. So therefore that T is time constant, and time constant is nothing but some sort of delay. So when I'm asking, do they have any drawbacks? These drawbacks means it might introduce some sort of delay. That's the answer. Does anybody have any question? Okay. So therefore the graduate students, because you were not asked this question at this point, you just note down the answer. Again, like after the class, I will be writing down all the answers and I will make it available. Although in the last class I told, but still I did not post the answers for the last class. I will do both together. I mean these answers and then answers for the last class. Now you see the code CEC 6205 for the graduate level. Question was on for you, but undergrad, everybody please look their question so that you can learn from it. Okay, so this very important question. Question was, for a flywheel energy storage system, instead of an induction machine, if a synchronous machine used, will there be any issues with energy storage operation? Explain your answer. So you all have studied that for the operation of flywheel energy storage, induction machine is used. Like flywheel stores the energy by its rotation or movement, and when it needs charging, then it works as a motor mode. When it needs discharging, it operates at a generator mode. And how that charge discharge happen? With the change of speed or velocity of that flywheel. This means because induction machine can work in a varying speed mode or the variable speed mode, that's why induction machine is chosen for the flywheel. On the other hand, if you choose a synchronous machine that cannot handle charge and discharge, it can store energy. I mean, synchronous machine is moving. First of all, synchronous machine always offers a constant speed. It's a constant speed generator or the machine, whatever it is, motor mode or generator mode. So that's why if you attach a flywheel to the rotor body of that synchronous machine, then of course it will store energy and it will work as standby mode, a normal mode. But when you charge and discharge, because you have to change the speed, that synchronous machine cannot handle that change of speed. That's why you cannot charge and discharge. So when I'm asking, will there be any issue with energy storage operation? So the answer is yes, there will be issue. It can charge and discharge because synchronous machine cannot accommodate with the change of speed. That's the answer. But of course, it can just hold the energy. But if you just hold the energy, you cannot utilize it. It does not make sense. So that is the issue. Uh, First of all, the graduate student, do you understand my answer?
Yes.
Okay, so Manoj, yes, I think that is the appropriate answer. Now, undergraduate students, did you understand the question and answer? This is very vital, very important question. So keep in mind, like undergrad, that I might ask you these similar questions for the final exam again. So
That's what I was about to ask.
I might not ask for the graduate student, but I might ask you. Yeah, that's why like I'm sharing the questions. You know that as a policy, we have to make even the little difference between 6-05 and 4-05 in the exam. So that's why always like I make change or difference at least in on questions. Okay, but for your learning, because it is the same class, for your learning, I am sharing these questions and that you have to understand. Okay.
Well, I was going to ask, will you be sharing the written solutions of both classes with everyone?
Yeah. I will do. So today I will be posting the answers for both. I mean, I will be uploading, in separate place on eCourseWare, so that you could see the whole thing. Yeah. And also, as I told you that for the answers of the last class, still I didn't upload. I have prepared the answer, but I will be uploading soon. So both today's class and then previous class, you could see together the answers, full answers. Okay, now you see question number B. What are RTU and PMU that are used in smart power grids and how do they differ? So, I think in last class we are discussing RTU stands for Remote Terminal Unit and PMU stands for Phasor Measurement Unit. So those two are the measurement devices. So you just need to answer what is RTU, what is PMU, what do they stand for, and what do they do. So basically, they collect voltage signal, current signals, or other signals, and with the help of sensors, they send those signals to the SCADA. So that is the role of RTU and PMU. Basically, the signal collector, voltage signal, frequency signal, or other signal. Now, when I'm asking how do they differ, what's the difference? RTU can take or measure only the magnitude. For example, only voltage magnitude, only current magnitude. But PMU has the capability to measure both magnitude as well as the phase angle. So because it can capture phase angle, so you could say PMU is kind of vector device and RTU is kind of scalar device because it can capture only magnitude. So it's equivalent to a scalar device. On the other hand, PMU can capture both phase and then magnitude. So this is kind of phasor. And these days, our engineers have started using PMU or preferring PMU over the RTU. So that's the difference. So everybody understands? First, the graduate students.
Yes, yes, doctor.
Okay. Okay, now from two, now I think Alajmi, so you are talking from question number 2, it is the same for both grad, undergrad. Therefore, everybody please look. And this is another very vital questions. Question was for the following photovoltaic PV system shown in figure on, if an energy storage, I mean, whatever the type of the energy storage, that does not matter. An energy storage is connected between the inverter and transformer. So see the location. This is the connection point. This is inverter and the transformer. This means this is the AC side. Okay. And also solar irradiance randomly varies. This is PV system. Continuously solar irradiance is varying. Then how do the PV panel output power and grid power behave? Explain your answer. So what I am asking, under this condition, what will be the power look like right at the PV panel terminal? And what should be the grid power, or how does grid power behave? Grid power means after the transformer or whatever, before the transformer or after the transformer, how the grid power look like. So what answer did you write, graduate student? Or anybody? So undergrad students, so what answer did you write for this one? How does the
I said, Dr. Ali,
yes?
I said the system will behave fully fine because of the energy storage system will take care of the fluctuation in the radiance.
So, but everybody see, here is the catch point, very critical question. I am asking, how do the PV panel output power? So PV panel output power is here. So there will be fluctuations.
Yeah, that will vary. That's what I wrote, I think. Yeah.
But everybody see, everybody look, the energy storage is here. So what will happen before connecting the energy storage? I mean, this point, DC-link point or PV panel point, still the output power will be fluctuating. But from the connection point of the energy storage, this means after this one, the power will be smooth. Do you understand? So
But Dr. Ali, like when you say output, you mean the output overall, right?
you see, there are two things. Read the question. How do the PV panel output power and grid power? So grid power means where is the grid after the transformer? The grid on the AC side. So two questions. PV panel output power means right at the PV panel terminal. So at that point, DC-link point, still it will be fluctuating. But at the connection point, after the connection point, then it will be like mitigated or the suppress those fluctuation. So at the output terminal of transformer, or in other words, at the grid point, so the rest of the grid will see the smooth power. But before, now everybody see, if I connect the energy storage here, right at the PV panel terminal, so everybody please understand, if I connect an energy storage right at the PV panel terminal, then from that point to the right side, everywhere power will be smooth. Now again say, if I connect an energy storage at the DC link point, then on the left side of the DC link point, still power will be fluctuating, but from the connection point to the right side, everywhere it will be smooth. Do you understand? So that was the question, that energy storage is there. This does not mean that it will make the smooth power everywhere. So I am asking two locations, one at the grid point and at the PV panel output point. Othman, do you understand now?
Yes, because I was confused. Like in the exam, I didn't accept you are asking 2 points. I thought it's only 1 point, which is the grid. That's why. Now
You see, that's why I asked this question. Do the PV panel output power and grid power?
Yeah. I thought like only grid. That's why I get confused.
Yeah.
Makes sense.
Everybody, do you understand? So this is very important. Now, if you see, again, look, if I connect the energy storage at the grid point, for example, just at the grid point, this means anywhere in the left side, there will be fluctuating output. But because I said, okay, energy storage is connected between inverter transformer, after that power will be smoothed. But before that, anywhere in the system, there will be fluctuations because solar irradiance is varying. So these are very critical questions. I mean, not difficult questions, but very critical questions. So you just need to think. So I am evaluating your exam paper. So once I finish, then I will get a clear idea how everybody you write and what you did. And next class I will be sharing. Okay, another critical question number B. Does the frequency of the grid depend on the solar irradiance or temperature of the PV panel? Explain your answer. Now you see, when I am asking does the frequency of the grid, this means because the grid is the AC, so it has the frequency. So does that frequency is dependent on solar irradiance or temperature? You know, on the PV panel or the PV system, performance is dependent on two parameters. One is solar irradiance and other one is the temperature. So is there any relationship here and then here? So what did you answer? Othman, what did you answer?
I said it depends on the solar irradiance because solar irradiance produce the output. Depend on that. Sometimes frequency change.
So what is the output? What type of output solar array produce? Is it AC or DC?
DC.
DC. Then is DC dependent on frequency?
No.
No. So that was the critical question, because this is the DC system. So DC, there will be fluctuations, but then there is, DC to AC inverter, and then there is controller that will match what frequency is needed at the grid. So after the inverter, you can see properly what frequency is needed, 50 hertz or 60 hertz, depending on the system or the location. So do you understand? Because but if it would be like wind generator system, because wind generator produces AC, then you could say the grid frequency is dependent on the output of the wind generator. Or for the conventional system, if it is synchronous machine, then still frequency would be dependent on the machine output. But in this case, it is the PV, so it is producing DC. So DC is independent of frequency. So there will be fluctuations, some other things, but all will be changed or modified with the help of the controller to match with the required grid frequency. So the frequency is independent in that case. It does not depend. Is this fine?
Yes. I wanted to ask, I believe we were taught that the frequency of the grid is not supposed to change. So how do you compensate for something like a wind generator changing the frequency of the grid because it's AC power?
Yeah, so again, if you remember the construction of wind generator, I mean, there is similar, if it is permanent magnet synchronous generator like type 4 wind generator, then in between, I believe you can remember that wind generator produce AC. But because it is varying, its frequency is varying. On the other hand, grid, you need the constant frequency. That's why you remember first there is a rectifier on the wind generator system. That AC is converted into DC, and there is a DC link if it is a PMSG type of wind generator, and that DC is converted back into AC with the help of inverter. So if you remember the structure or construction of permanent magnet synchronous machine type of wind generator, which is like type 4, then there is power electronics in between. There are rectifiers, DC link capacitor, and inverter. That basically matches with the grid frequency. That makes the grid frequency 60 Hertz. Robert Hampton, so are you fine?
Yes, that clarified. Thank you.
Okay, and then if you still, if you now go back to type 3, type 3 is doubly fed induction machine-based wind generator. There is no power electronics between grid point and stator, but there is, and that is the reason it is called doubly fed. There is connection through the power electronics device between the rotor and the stator. Sorry, the grid point and then the rotor. So, and then typically that power electronics rating is about 1/3 of the machine rating. So, and then again, if you see in case of doubly fed induction machine-based wind generator, there is similar power inverter and then rectifier and DC link capacitor that basically controls the frequency. So therefore, like you are right, in case of wind generator, right at the wind generator terminal, definitely it is AC and frequency is varying. And then with the help of power electronics components at the grid point, the frequency is maintained at 60 Hertz or 50 Hertz, depending on location. So is everybody fine? So do you have any further questions or comments? I think everybody. So please, I would recommend you, because I will be posting the full answers. So I would recommend you, like at home, again, you please look all the answers and understand. That will help you learn the subject matter of this course. You will be learning a lot, and then again, you might expect similar questions in the final exam. So on that day, again, you have to write the correct answer. Okay, so moving forward. So next slide. Can you see my slide screen? Question number 3. Okay. So question number 3 was, in case of a pumped hydroelectric energy storage system, is there any preferred time of day, like in 24 hours, to charging and discharging? So once we discussed this question during the class, so you know that typically during night time, the electricity price is low and daytime price is high because of the high demand. So therefore, charging means working as a motor. The pumped hydroelectric energy storage system, it will be working as a motor mode to pump water or to lift water, and that is typically done at night time. And discharge means you have to send power to the grid based on the demand by the grid, and typically that is done during daytime. This means, I mean, in case of pumped hydro, because it is a huge system, it depends on geographical location or topographical location. That's why it is kind of, you can say, one charging and one discharging. Like machine started working as a motor to pump water or lift water, then that is charging continuously. It is going several hours altogether. And then discharging when it is sending power. It is not like that every second it can charge and discharge. It is not like that. It is unlike the supercapacitor or battery or superconducting storage. So I believe everybody have written the answer to these questions properly. So is everybody fine with this one? Okay, and then question number B, this is basically the class problem. I just changed some numbers. So here I'm not going to discuss B, but when I will be answering, posting the answer, I will make the solutions available. That time you can say. If you remember before the exam, we properly discussed this question. I just changed the values. I think it was 0 degree, I changed to 5 degrees, and it was not 120 volt, it was different value, but the statement was the same. But I am going to post the answers for this as well. Now you see question 4a, why does communication delay matter in a modern power grid? I mean, why we have to take headache? Or in other words, why it is important? So because communication delay will degrade the controller performance and hence the overall power grid performance, that's why communication delay matters. I mean, the reason I am asking this question, because those delay are not big. I mean, in terms of microsecond or several hundred millisecond, even not full on second or 2 second. That's why I am asking, why does those communication delay matter? So the answer is that in this modern grid or in this digital grid age, several hundred millisecond delay is enough. 1 second, 2 second is quite high. That's why it is matter. It is our headache. We have to take into account this communication or time delay for modern power grid to design any control system, to make any analysis, including stability, power quality, or any other dynamic performance enhancement. So is everybody fine? I think on the exam day, Othman was asking me what did I mean by this question, right, Othman?
Yes, I did, Dr. Ali.
Yeah. I think everybody have written. I mean, in other words, if you just write, what is the importance of considering communication delay in modern power grid, that will be fine. And then again, same way, we discussed this problem in the class. I just changed the values. Exactly the statement is the same. I just said, but as I said, again, I make the solutions available, so you will get it handy. Okay, this one, question number 5, everybody see. A solar photovoltaic system connected to a power network is facing voltage fluctuation issues. You see, in this case, I am saying, okay, there is only voltage fluctuations. This means we're assuming that there is not much change in the power. That is okay. That is acceptable within a range. But there is significant amount of fluctuations in voltage profile. Now, based on these fluctuation issues, which of the following devices would you choose to solve the issue? So this means in this case, issue means solution of the issue means you have to mitigate the voltage fluctuation. Look only the voltage fluctuation. Which device can do? Large capacitor? No, because it can consume real power only. So it has the capability to handle only active power, or hence the frequency somehow. STATCOM, static synchronous compensator. As I told you, this is advanced form of capacitor or improved version of control capacitor. So it has the ability to control reactive power. And as I told you before, reactive power control means voltage control. So you have to pick up the STATCOM. Large capacitor, you all know, everybody know that a capacitor can handle the reactive power because it can improve the power factor. So definitely you have to choose the capacitor. Flywheel energy storage, any energy storage device has the capability to control both real power and reactive power. In other words, because real power is analogous to frequency and reactive power is analogous to voltage, the question was voltage fluctuation. So definitely you can choose flywheel energy storage. Similarly, SMES, superconducting magnetic energy storage, you have to choose this one because it has the capability to control both active and reactive power and hence frequency and voltage. And then of course, battery energy storage, again, it has the capability to control both frequency and voltage. So you have to pick up this. So therefore, appropriate answer would be except large capacitor, like 1, 2, 3, 4, 5, and 6, you have to pick up. So everybody, do you get me?
Dr. Ali, I have a question.
Here.
Since you mentioned only voltage fluctuation, why do we need to use the energy storage? Because we don't need to control the frequency and the voltage. We only need the voltage. So we
Exactly.
are good with the STATCOM and large capacitor. We don't need controlling frequency, right?
Yeah. So that is right. But you have to look. I am asking that which of the following devices would you choose? You have to look that which devices has the capability to control voltage.
Yeah.
Therefore, flywheel, SMS, energy, any energy storage, they have two capabilities. So therefore, definitely you will be choosing those. Do you understand? Because already there is voltage capability on the flywheel, SMS, battery energy storage, or any other energy storage. Definitely I will be choosing. Plus the capacitor is STATCOM, they can control only voltage. They don't have the capability to control any real power or frequency. So that's why, of course, I will be choosing those two. And definitely I will be choosing each and every energy storage because they have both capability. So in this case, only voltage fluctuation is it, but still I will be choosing the energy storage. Now, if the question was like facing voltage and frequency fluctuations, both, everybody understand, is facing both voltage and frequency fluctuation, then definitely I will be choosing only the energy storage like flywheel, SMS and battery. If the question was that, okay, you have to mitigate, you have to handle both voltage and frequency fluctuations together, that time I must choose only those energy storage. Okay, now if the question is, now listen another thing, if the question is, I said, okay, facing frequency fluctuation, I said, just I say, I did not mention voltage, just the frequency fluctuations, I said. Then again, of course, all those three energy storage plus the large resistor. In that case, you can't choose STATCOM and the capacitor because capacitor and STATCOM cannot control active power and hence cannot control the frequency. Do you understand?
Yeah, but it is still confusing for us because you already, I mean, you only mentioned for, I mean, which one would you choose just for the voltage fluctuation? That's how I interpreted in the exam. So I didn't, I mean, deal with the active power thing. I mean, those frequency thing. So
No. So I think you didn't understand. You see, okay, so based on the question as it is, I'm asking facing voltage fluctuation issues, right? So you have
yeah,
to look which devices has the capability to handle the voltage, right? So
yes.
okay, first come this point. So what I said, the large capacitor, large resistor, first one, it can control active or real power and hence the frequency only. So
Yep.
you cannot choose that one, yeah.
Right.
Because it does not have the capability to control both. If it would have the ability to control both, for example, the resistor has the capability to control both, so you have to choose that as well. But you cannot choose because it can control only frequency. Now, STATCOM can control voltage,
Only the
voltage only.
voltage.
So of course, you will be choosing that one, yes. Large capacitor that can control voltage, of course, you will be choosing. What I am telling that any energy storage has the capability to control both. So you understand, because they have the inherent capability to control both, definitely you have to choose those as well. You see, definitely you have to choose because they have the both capability. So therefore, whatever I am saying, even if in the question I say, okay, facing frequency fluctuation, still you will be choosing those energy storage first because they have the both capability. Do you understand? But if the question is facing frequency fluctuation, then you can't choose STATCOM and capacitor because they can control only voltage, STATCOM and capacitor.
But for this question, we could choose anything from, I mean, number 2 to number 6, right?
Yeah. That I am saying. So therefore, what you have written 2 and 3, right?
Yes, of course, because I only thought that is, I mean, dealing with the
So
voltage
therefore,
fluctuation.
this means your answer is not full, but what you have chosen, that is right. Yeah. What you have chosen, that is right, but you did not take into account all devices. So this means
Because
your answer
yeah,
is partially right. What you have chosen, your chosen device is right. So it is not full answer, but of course I will.
No, I mean, we are confused about the question because we all know, I mean, how these things, this component will work, which controls frequency and voltage. But the thing is, like, the question was asked in the confusing way. Okay, I mean, just to deal with the voltage or just to deal with the frequency. So we thought in that way. That's why. Okay, it's fine. It's fine.
Yeah, but now do you understand that
Yeah.
because they have the both capability, so you have to choose those energy storage. So that's
Yeah.
why I said, I mean, keep in mind, if the question is just voltage or only frequency or both voltage, definitely you will be choosing all of the energy storage. That is the first thing. And
Yeah, I
then
mean,
the remaining list, you will be looking what capability they have. So in this case, question as voltage, so you can choose the resistor, but the wall. If the question is frequency fluctuations, this means you cannot choose start common capacitor if it is the frequency, but then remaining all. When it is, the question is, okay, facing both voltage and fluctuation, so you have to give priority to solve simultaneously or altogether that voltage frequency. That time you will be choosing only the energy storage device. Is this fine now?
yeah, but I mean, it's kind of like, I thought it, I mean, I went into the depth and thought it was like objective question. So
Yeah.
it's fine. It's fine anyway.
Yeah. No, it was objective. You are right, but you picked up, I mean, less devices. Yeah. Yeah. So I mean, you can do. See here, like for example, let's say energy storage device has 2 to 3 capabilities: voltage, frequency, power factor, for example. And then if any of those parameters are there in the question that you are telling object, definitely you have to choose that one. Yes. That's why, I mean, it is not just choosing one component or just 2 components. Which of the following devices? This means you can choose multiple. But anyway, because I mean, those who have chosen like few components, still you will be getting credit for that question. It is not 0. I mean, your answer is not full. Yeah, but still your chosen device is correct.
Yeah, I think I got full.
Okay.
It's fine. Yes, it's fine, Doctor. Thank you.
Okay. And then again, like question number B, numerical problem. As you can understand, we discussed in the class. Here I just changed the number, as you can understand. Like turn ratio in the class, I think it was 2, 1, then I changed 3, 1. Like every parameter I just changed. That's why I did not solve here right now, but I am going to upload the full solutions and full answers of everything. So is everybody fine? Does anybody have any other questions and comments?
No, sir.
Okay. So but then thanks everybody. So that's all for today. So hopefully next class I will be sharing you the I mean beforehand I think during weekend I might share you the grade for your midterm exam. And I think I will be writing the comments, annotations on the Dropbox, so you can see what comment I made, and I discuss the answers, and I am going to make it available for you to compare your answers. And then after that, if anybody have any questions, comments, then you can contact me.
I do have one question, Dr. Ali.
Yes.
You know how during the test I had scanner issues. I just want to make sure that
Oh
you
yeah,
got
yeah.
the
You
ones
sent
from.
me an email. I received your email, so I think you are fine. Yeah, you are fine.
All right, just verifying. Don't want to get a 50.
No, so you are fully fine. I think you mentioned me scanner issue, and I received few other emails about scanning and etc. But I will be considering. Although we scan through, I mean, the cell phone, and we got a little bit faint, but I will see it, and I will try to understand, and I will properly grade. So becoming it will not affect your grade. Yeah.
I was about to say we do have a new one, so that should not be an issue in the future.
Yeah. So I mean, what I am saying that I am trying to be a little bit flexible because of this, that online system and some of the issues are going on. So like you are fully fine. You are fully fine at this point. Okay, so any other questions and comments from
So,
anybody?
so we still have like third exam left and the final, right?
I think in the schedule, I did not mention. So do you like to go the third exam, everybody? So, or what do you think? I mean,
Yeah, because
if I go the third midterm exam, then what I can do among the third midterm, three midterm exam, I can pick up the best two. So
yeah, I think that
That
could be
sounds
great.
good.
okay, so everybody wants that way.
Yeah.
Okay, therefore let me fix a date. Then it could be probably 23rd, because 28 is our like last class of this semester. So probably 23rd. So let me think, and then I'm going to send out an email to everybody.
Okay, thank you.
Yeah, and but definitely I'll be considering, and I will try my best.
Dr. Ali,
Yes.
is the final optional or required?
A final is required. Everybody must attend the final. Everybody must attend the final. That is required. But what I told that if you give midterm exam 3, then among the 3 exams, I will be picking up the best 2. For example, Enon got you 80, Enon got you 90, Enon got like 50, just a random example. Then I will be cancelling the 50. I will be picking your best 2, and then I make an average there for the midterm exam. But final exam is compulsory for everybody. Everybody must attend. Is this fine?
Yes, thank you.
Yeah, we already discussed, these things before we start of these online systems during the upfront class. We discussed. Okay, so therefore everybody, I mean, don't worry. You just please keep going. Everybody attend the third exam, and you submit your homework too. I think due next Tuesday, and then at the end of the semester, we see where you stand, and then you will be doing final exam. And you all are doing this project presentation, and one more project is remaining, written document. So your grade will be based on everything. And as I already told at the beginning of the semester, of course, always I give some grace credit to everybody. So everybody will be fully fine, I believe. Anything else? Okay, then I'm going to, fix a date for the midterm exam 3, and I'm going to notify you all. Okay, then. So with that, I like to end the meeting here. So everybody, I mean, have a good day, have a good weekend, and everybody please be safe. See you next week.